Now we'll cover each of the LC3 instruction types. Let's start with the operate instructions. There are three of those: add, and not. And the source and destination operands are either register values or immediate values. Now, in the immediate version, one of the operands is actually embedded in the instruction as a constant. So we're adding a value from a register to a constant. Now, the result of these operations gets written to a register. So these instructions do not touch memory. We're always dealing with register values or constant values and not going to memory here. Here is a not instruction. It has opcode 1001, and there's only one source register, and that's bits 8 through 6. We read that out of the register file. We send that to the ALU. We tell the ALU to do a not, which means that every bit gets inverted, and the result gets written to the register that's denoted by bits 11 through 9. That's the destination register. Now, the source and the destination register could be the same register. We could say read R2. We could not those bits, invert them all, and write them back to R2 if we want to. The add and instructions are identical except for the operation performed by the ALU. With both of these in the register mode, we read two source operands from two registers, and that's denoted by bits 8 through 6, and the second by bits 2 through 0. We do the operation, either add or and then we write the result to the destination registers indicated by bits 11 through 9. Now, bit 5 is a 0. That tells us that this is register mode. That tells us that both of our source operands are coming from the register file. In the immediate version of these instructions, the second source operand is an immediate value, a constant that's in the instruction itself. So here we have bit 5 being a 1 instead of a 0. That indicates that our second source operand is an immediate value. Now, that's indicated by the rightmost 5 bits of our instruction. Now, because we're going to add that to a 16-bit value from a register, we need to assign extend that value. We need to duplicate bit 4 11 times to get an equivalent 16-bit value that then we can add to the other source register. And the result, of course, goes into the destination registers indicated by bits 11 through 9. Now let's go back to our LC3 microarchitecture and add support for register in immediate modes. What we're going to add is a multiplexer we call SR2 mux. So this indicates the second source operand for those instructions. Now, in register mode, that's going to come from our register file. So that's one input to the mux. In immediate mode, that's going to be the sign extended immediate. So that's the other input. And then the finite state machine control is going to pick one or the other depending on the type of add and instruction we have.